We're going to be talking about redox reaction, both acidic and alkaline medium. So how can we do this? So let's start practicing some questions. So look at these two redox reactions. So we are asked to balance this. So first, what can we do to balance this equation? So to balance this redox reaction, first we're going to find which one is the oxidizing agent and which one is the reducing agent. As you can see here is the reducing agent. Reason because iron is the reducing agent. Reason because it is the one that is oxidized, while chlorine is the oxidizing agent. Why? Reason because it's the one that is reduced. So solution, first what you have to do is to find the oxidation number. So oxidation number of iron here is +2, oxidation number of chlorine here is 0, oxidation number of iron here is +3, and the oxidation number here is -1. So we have to take the oxidized and reduced. Which one is oxidized? As you can see, iron is oxidized, so we're going to do iron +2 will now give us iron +3. So we're going to add electron to balance the total number of atom. As you can see here, the atom is balanced, but the total number of electron is not balanced. So to balance the total number of electron, we are going to add 1 electron. So that if you have 1 electron, so that here will be 2 electron and here will be 2 electron. So for the reducing agents, as you can see, here is chlorine, which will give us chloride ion. So here we have 2 atoms of fluorine, while here we have 1, so it's not balanced. So what we're going to do is to add 2 to balance the number of chlorine. So the total number of chlorine is not balanced, but the ion is not balanced. So here 2 times -1, which means we have -2 electron here. So here we have 0. So what can we do to balance the total number of charge? So to balance the total number of charge, what we have to do is just to add +2 electron to balance the total number of charge. So here will now become 2 chloride ion. So the oxidizing and the reducing agent is balanced. So what we have to do now is to equate them in an equation. So to equate this in an equation, we have to balance the total number of electron. So here we have 2 total number of electron, while here we have 1 total number of electron. So what we're going to do is to multiply here by 2 and multiply here by 1 to balance the total number of electron. So multiplying here by 2, we have iron +2, which will now give us iron 3 ion, plus multiplying here by 2, we now have 2 electron. So we have to multiply this equation by 2. And for the chlorine ion, for the chlorine, we have to multiply by 1. So multiplying by 1, we have no change. So here now we now have 2 chloride ion. So since the total number of electrons is equal to the total number of oxidizing electrons is equal to the total number of reducing electron, so what we have to do now is to cancel out. Our aim is to balance this redox reaction. To balance the redox reaction, the electron must be in the opposite side. For instance, electron cannot be here and electron be here. So electron must be in the opposite side for this reaction to balance. So as you can see, electron is in the left hand side, while for ion, electron is the right hand side. So what we have to do now is to cancel out. So cancelling out the electron, what is remaining now is to write this in a very good half equation manner. So writing this in a good equation manner, we now have this. So you can start from iron, you can start from chlorine. Anyone is not depend on your choice. So let's start from iron. So here now we now have 2F plus 2 ion plus chloride 2, which will now give us chlorine, which will now give us 2 ion 3 plus 2 chloride ion. We have write this. You can start from you can start from iron or chlorine depending on your choice. So the choice now lies on your hands. So let us check whether this is balanced. To check whether this is balanced, if the total number of charge is not equal to the total number of charge in the left hand side, is wrong. So in my left hand side I have 4, because these two we multiply these two, giving us plus 4, which will now give us here 2 multiplied by this time we now have 6, minus 2 multiplied by minus we now have 2. So here is plus 4 and here is equals to plus 4. So this reaction is balanced because the number of charge is equals to the total number of charge in the right hand side, total number of atoms is equals to the total number of atoms in the left hand side. So the reaction is now balanced. So let's go back to more complex one. So look at this equation. First, what are we going to do? The first thing we are going to do here is to check the oxidation number. So to check the oxidation number here, the oxidation number here is plus 2. We're checking the oxidation number to identify the one that is oxidized and the one that is reduced. So the oxidation number here is 4. I've taught you how to calculate oxidation number in my former video. So if you don't know how to calculate oxidation number in my video, go back to my video so you understand how to calculate the oxidation number. But if you can calculate, fine and good. So here now we have equating this compound. We now have 4 times minus 2 will now give us minus h is equals to minus 1. So minus 8 crossing over here will now give us plus 7. So the oxidation number here is plus 7, while the oxidation number here is plus 3, and the oxidation number here is plus 2. So let's go ahead and balance this equation. In balancing this equation, what do we need? Let's go for the oxidation. So which one is oxidized? As you can see, here was plus 2 and here was plus 3. So the one that is oxidized is iron. So iron to the both hand side of the equation, which will now give us. So to balance this, we're going to add 1 electron so that the total number of charges is equal. So we now add 2 electron, 2 plus, which will now give us 3 plus 1 electron. Now we now have the total charge to be plus 2 and plus 2. For the reduction, so for the reduction we have manganese and this. So first we're going to balance the number of atoms. So from this equation, the number of atoms of manganese is balanced. So how can we balance the number of oxygen? So to balance the number of oxygen, we're going to add 4 molecules of water to the right hand side to balance the number of oxygen. You're not going to add oxygen directly. We cannot add oxygen directly unless we are solving for different something. But in redox reaction, we have to add total number of oxygen to the left hand side, to the right hand side, to balance the number of oxygen, which is here now we have 4 molecules, we have oxygen. So to balance the total number of oxygen here, we have to add 4 molecules of water, and these 4 molecules of water contains the same amount of oxygen here. If 2 was here, we're going to add 2 molecules of water. If 1 oxygen was here, we're going to add only 1 molecule of water. So since 4 molecules of water is here, if you check here, we now have 8 hydrogen ion. Remember that we're balancing this then in acidic medium. We're going to still balance in basic medium. So here now contains 4 times 2, which is now 8 hydrogen ion, which will now give us manganese 2 plus 4 molecules of water. So is this equation balanced? Nope. So to balance this, we're going to add how many electrons? So since here is minus 1, here will be 8 times plus 1, which will now be 8, and here will now be plus 2. The charge here is 0. So here will now be plus 7, and here will now be plus 2. So to balance this, we're going to add 5 electrons so that the total number of charge will be equal. So here will now become 2 plus electron, and here will now become 2 plus electron. So implementing this in the equation, we now have manganese O4 minus plus 5 electron, which will now give us manganese 2 ion plus 4H2O. So let's write the, as you can see here is 5 electron, while here is 1 electron. So to balance this, we're going to multiply this equation by 5 so that the total number of electrons will be equal. So multiplying here by 5, we have that here will now become 5 plus 5 electron, which will now give us 5 plus 3 electron plus 5 electron. So this is now balanced. And how are we going to check whether this is balanced? Because this electron are in opposite side, while the water is also in opposite side of the reaction. But let us not consider for the water, because we're going to balance the water separately. We're going to consider the water when doing alkaline medium. But since we're doing acidic medium, what we are confirming now is our electron. So since the electron are in opposite side, they are completely balanced. So what least to do now is to write this term very well in order for us to view it in a very appropriate manner. So you have 8 hydrogen ion plus 5 electron, which will now give me manganese 2 ion plus 4H2. So since the electron now are balanced, so we're going to cancel out the electron since they're in the opposite side of the equation. And since this are in the opposite side of the equation, this is telling us that what we are doing is correct. If they're in the same side of the equation, which means they are very wrong. Here, the electron in the manganese is in the left hand side, while the electron in the ion is in the right hand side. Telling us that what we are doing is correct. So we're now going to go ahead and write this as a single equation. So writing this as a single equation, we have that ion, we can start from ion, we can start from manganese. So let me decide to start from ion. So I have that ion 2 ion plus manganese O4 minus plus 8 hydrogen ion, which will now give me manganese 2 ion plus 5 ion plus 4H2. We are not going to write the electron because they will cancel each other. So let's check whether this ion is balanced. If this ion is not balanced, which means what you're doing is wrong. So how many total ion is here? We have 10 minus 1 because 1 is here. Because 1 is here, and we have 8 times this, and we have plus 8 ion. And here we have 2, which is plus 2 plus, here we have 5 and 3. So here will now become 15, which is 17. So 1 minus 10, we have 9. 9 plus 8, we have 17 plus, and here we have 17 plus. So they are balanced, stating that what we do is absolutely correct.